Okay, so the recording has started, so let's dive into today's lecture. Okay, now what's going to happen is in the last class we discussed about different metrics, right? For example, how to measure. Well, we have been discussing about accuracy, but then we went on and discussed about other metrics like precision, recall, F1 score, right? All those metrics we have discussed. Okay, so here's an example I just wanted to give you so that you're aware how to actually calculate or how to actually how to actually find all these values, okay, in scikit-learn. So I'm going to very quickly show you that. After that we will move into linear regression. So let me show you here. So if I go to eDrive and then I go to, okay, let's say here, okay, I think inside teaching, yeah. Let's see what we have. Okay, remember আমরা একটা workshop arrange করেছিলাম যেখানে we have discussed how to actually work on the data set. So let's go inside this workshop and let's open up Jupyter notebook there. Okay, so I'm going to click on this one. So I'm not going to go through this entire notebook because this is the notebook that we have discussed as a workshop material, and this has been already uploaded as well. But there's something that I have added over here. This is already something that you will find in the workshop that has been uploaded, but I'll discuss this quickly. Okay, so here we are. So we have been using different kinds of models, different kinds of classifier like zero classifier, decision tree. Okay, so what else we have used? After that, we have used something called Euclidean distance, KNN with Euclidean distance metric. This is the logistic regression. This is the naive-based classifier. Here's the support vector machine, support vector classifier. So I'm going to show you for one of the classifiers. Let me show you for the support vector machine. How do you find out other things like, precision, recall, because you have been so far calculating only the accuracy, but we need to measure other metrics as well. So I'm going to very quickly show you how you do that. Okay, so are we there? Can you see my screen? Yeah, can you see that? Okay, so here it is. So if I'm using support vector machine, this is something we have done in the workshop, but very quickly. From sklearn.svm, I have imported support vector classifier. Now this is the classifier, which is support vector classifier. There's something called gamma variable. I put it as auto, and then the random state is 0. Dot fit will fit train, right? Like in X train and Y train dilan, and it will train the classifier. And then if you want to predict, CLF.predict, you put the training set, and this is the Y predicted value of the training set. And if you give the test set, CLF.predict will give the corresponding prediction of these X tests, so which is stored in Y predicted test. Now, in order to find train accuracy, you use something called accuracy score, and you give the predicted train value and actual train value. This will give you the training accuracy, which is 85% here. And if you want to find out the test accuracy, give the predicted test value and the actual test value in the accuracy score function. That will give you the test accuracy. So this is something we know, right? Are we okay? Yes?
Yes, sir.
Acha. Now, let us say I want to find out other metrics, like I want to find out recall, precision, F1 score. How do you find this out? Okay, very easy. So what you need to do in scikit-learn is something like this. From sklearn, you have to import something called metrics. And then if you want to generate a confusion metric for the test case, I'm showing you for the support vector machine. So if you're doing for other classifiers, where other classifier accuracy you use the same code and you should be able to get these metrics for other classifiers. Okay, so I'm showing it for this support vector classifier. So I've imported the sklearn from sklearn.metrics. Sklearn, I've imported something called metrics. Then I'm generating a confusion matrix. So confusion matrix for the test case. So all you have to print is something called metrics dot confusion matrix. Okay, and you have to give the actual test value because we're generating this confusion metric for the test case, not for the training set. Okay, so I'm giving the actual test value and I'm giving the predicted test value by that support vector machine. So if I pass these two parameters in this particular function called confusion underscore matrix, this will generate this confusion matrix. Okay, so 28, 5, and 27. Now, for this one, this is the actual, left actual, আর উপরটা হচ্ছে predicted. ঠিক আছে? Okay, so that's this one. And then if you want to find out precision, recall, and F1 score and stuff like that, all you have to do is you have to, well, I printed classification report so you can see that. So there is something called matrix.classification report. You're going to again give these two things, y test, y predicted, and I'm also specify করে দিয়েছি digits equals to 3 decimal place পর্যন্ত allow করা, ঠিক আছে? That's all. And if we press and enter, okay, if we run this one, matrix classification report, it will actually create something like this. Okay, so you can see precision will be 0.8. Okay, recall is 0.714, F1 score is 0.77755 for predicting the classes with the class value 0. In order to predict the classes with the class value 1, the precision was 0.771, recall was 0.844, F1 score is 0.806. You see the point? And it also calculates the accuracy, which is 0.783, and it actually matches because we found that the accuracy for the test case it was 0.783. So many threes, but because I limited the digits to 3 decimal places, so it's giving me the values to 3 decimal places. Are we clear, Nakina? Is that okay? Yeah? ঠিক আছে? Are we happy? Okay, so similarly support vector machine না করে যদি আমি অন্যান্য ক্লাসিফায়ারের জন্য করি for logistic regression, for let's say KNN, you use the same code after that and you should be able to get precision, recall, and F1 score and stuff like that. So we know what these are, we have calculated them, but this is just like how can you find this out in scikit-learn. Okay, so that's just something that I just wanted to talk about. I hope that's clear, right, Nakina? Is that okay? Yes? ঠিক আছে আমরা?
Yes, sir.
Okay.
Yes, sir.
Good. So what are we going to do today? We're going to look into something called linear regression. So I hope we're going to discuss what is linear regression in today's class as well as in the next class. So এই দুটো ক্লাসে আমরা linear regression নিয়ে কথা বলবো. Last class I'm thinking of talking about something called clustering techniques. ঠিক আছে? Okay, unsupervised learning and how can you do clustering. It's a very important thing, interesting technique that we're going to talk about clustering in the last one. So that's our target. So let's not waste our time. Let's move into linear regression. So we're going to discuss linear regression in today's class and in the next class. Okay, right. So let's get started. Shuru kori linear regression naki na? Yeah, shall we? Acha. I want everyone to be, little bit careful right now. Take a chance, okay? I want everyone to be very, very careful right now. Okay. What I'm going to do now is I'm going to talk about, the idea behind linear regression. Okay. I'm not going to show you how to actually, use the scikit-learn to do linear regression. ওখানে just একটা line use করলে linear regression হয়ে যাবে, ঠিক আছে? But I'm going to talk about the very idea behind the linear regression. Is it okay, Nakina? Clear? Are we good?
Yes, sir.
ঠিক আছে? আচ্ছা. Now, I hope you remember that when we spoke about machine learning, we say machine learning problems can be broadly classified into two kinds of learning problems. One is called supervised learning problem, right? Yes. And there is another one called the unsupervised learning problem, right, Nakina? Yes? Correct? Acha. Unsupervised learning problem, we can use something called, let's say, clusterings and stuff like that. That I am hoping that I'm going to show you in the last class. Okay. Now, in the supervised learning problem, what we have is we have, data set, which is X and Y. Okay. So we have X, the features, and Y is the target value which we want to predict. Now, if this Y value that we want to predict is discrete, then this is a classification problem. We spoke about that, right, Nakina? Yes? ঠিক আছে আমরা so far?
Yes, sir.
Yes, sir.
Okay. But if Y is not discrete, Y is, let's say, continuous, then it is not a classification problem. It is a regression problem. Okay. So today we hope to discuss the regression problem. In fact, we want to talk about one kind of regression problem called the linear regression problem. We could have polynomial regressions and other things, but if you understand the basic of linear regression, you will understand polynomial regressions and other kinds of regressions. Okay. So this is the basics. So we're going to focus on to linear regression. So that's what we're going to discuss in today's class and in the next class. So I hope we make it clear that what we want to do in today's class and in the next class, right? Nakina, yeah. Okay. Now, Sir Francis Galton is actually often attributed as the father of linear regression. Okay, or it's just history for you to know. So basically, what is linear regression? Okay, linear regression আমাদের যেটা আছে সেটা হচ্ছে আচ্ছা first of all I'm going to show you an easier version of linear regression, okay, which is called the linear regression with one variable. Okay, all right. Of course, the idea, once you understand how you can do linear regression with one variable, you can actually extend it very easily to linear regression with multivariable. Okay, all right. So linear regression with one variable, a very fancy term of that is sometimes we call it the univariate linear regression. Okay, sometimes you'll see in many papers they write, okay, this is an example of a univariate linear regression. Now, what does univariate linear regression mean? This is a linear regression with one variable. What does linear regression with one variable mean? It means that, you know, you have a data set, because this is still a supervised learning, right? So you have got features and you have got target. If you have just one feature and one target, so if you have only one feature, this is an example of a one variable linear regression or a univariate linear regression. Is it okay, Nakina? Clear? Are we good? Yes?
Yes, sir.
Okay. So that's a univariate linear regression. So let's say that we have got only one variable. The feature is plotted on the x-axis, and the y value is plotted. This is continuous value, so it's plotted on the y-axis. So let's say these are the points we get. Okay, right? Okay. Now let's say I want to know the a particular value of x corresponding y value key house. What would be the predicted y for this value of x, which is somewhere between 20 and 30. So I would guess this is 25. So one of the ways that you do is you draw the best fit line. Now, once you draw the best fit line, then, okay, for this value of x, you're going to find out the corresponding value of the y, right? But this corresponding value of y that you're getting is the predicted value of y. Nakina, yes, this is what your model is predicting it, right, Nakina? Yes, clear?
Yes, sir.
Okay, so in order to predict the value of y, what you need to do therefore is you need to draw this best fit line, which is called the regression line. Is it okay, Nakina? Are we good?
Yes, sir.
Okay, so that's what we're going to discuss, how to actually find this regression line from this data point. Now, have you ever done this one before in any of the courses where you have got data points like this and you found the best fit line? Did you ever do that before? কখনো করেছিলে? Physics lab করেছে. How did you find this best fit line? What did you do to find the best fit line? So physics lab কি just like points ছিল, তুমি তোমার মতো যেটাকে best মনে হচ্ছে তুমি draw করেছো এটাই?
Yes, sir.
You found the regression line.
No, we didn't find the.
You didn't find the regression line. Okay, fine. Okay, but we want to find the regression line from these data points. So that's what we want to achieve. Okay. Now, if you have done a statistics course, I don't know whether you have done this in the statistics course or not, but typically in any basic statistics course, they also teach you how to find this regression line or how to find this best fit line. What is the equation of this best fit line? They've actually find this out. Okay. And they typically use some interesting formulas, that has to do with correlations and other stuff like that. Now, what we are going to do in machine learning, we are not going to use those equations that the statisticians use. Rather, from these data points, we're going to learn what is the best fit line. That's the whole point. That's why it's machine learning, okay? And we'll see how to do that. Don't worry about that. So, an example of this univariate linear regression will be this. So let's say you find some data points, okay, of the housing prices in Portland, Oregon, okay? So you know the housing prices, these are the prices in thousands of dollars, okay? And this is the size, okay, of the house. How much is the size of that particular house in feet square, okay? So you see, kind of interesting, I can draw the best fit line, okay? Okay, so let's say now if I'm interested that I find a house with a size of 1250 square feet, I would like to know what would be the corresponding price that I could expect this house to be. So what I need to do is I need to come up with this best fit line, okay? And so I can then find out from the I can then plug this x as 1250 and can find out the predicted value of y, which is something like $220,000. Is it clear, Nakana? So we would like to find this regression line. How to find this regression line is our objective today. Okay, right? Are we good so far? So far, so good. Yes or no?
Yes.
Yes, sir. Okay, so we understand that. Remember, in a regression line, the y value, what we are trying to predict, is a real valued output. So this is a continuous value. This is not any kind of discrete value. This is a continuous valued output. So we have got training set. So we want to learn this line, okay, using machine learning. So we need a training set, right, Nakana? So let's say here's an example of a training set, okay? So we know different houses with different size, okay, in feet square. These are the x, okay, and this is the corresponding price. So 2,104 square feet has a price of $460,000 US. 1416 square feet has a price of $232,000 US, and so on. So we have got a data set. Is this clear? From this data set, I would like to find out this line, or this regression line. If we find this regression line, then we can predict for any value of x, we can find the corresponding value of y. Are we good, Nakina? So far, so good? Yes?
Yes.
Okay. Now, certain notation is important. Now, you need to be a bit careful right now because I'm going to use a lot of mathematics. Well, I won't say a lot of mathematics, but I'm going to use a decent amount of mathematics here. So in order to use mathematics here to understand the problem, I need notation. So here is the notation here are some notation I'm going to use. M is the number of training examples. That means this is the training set size quota. How big is the training set? That's represented by M. X is the input variable or the features, and Y is the output variable or the target variable, right, Nakina? So you already are aware of that. Sometimes we do not prefer to put X as small x, sometimes we write X as capital X, but Y as small y. Okay, but that's okay. But here, because I'm using only one feature, okay, it's a univariate linear regression, so small x is very fine. Okay, now here's an example of that one. So if we want to know, my first training set is this one. This is my first training. This is my training set. The entire thing is my training set. This is my first, instance. That's my second instance. That's my third instance, and so on. Clear, Nakana? So I can say x1. So what is my x1? 2,104. Am I clear, Nakina? Yes? First instance x value is x1. x2 means second instance x value, which is 1,416, right? Okay, y1, first instance of y value, which is 460. y2 is 232. Are we good, Nakina? So far, so good? Do we understand this notation?
Yes.
Yeah. Okay. So what are we gonna do? What's the objective? Objective was we have a training set. So like this, we have a training set. So we want to learn that regression line. So what we're gonna do is we're gonna apply a learning algorithm on this training set. So I'm going to supply this training set onto a learning algorithm. And what will the learning algorithm do? It will use the training set to learn something. Is that right, Nakina? Yes, correct. It is going to use the training set to learn a model. Am I right, Nakina? Yes?
Yes.
So that's what is the learning algorithm going to do. The learning algorithm is going to use the training set to learn a model. This model is sometimes referred to as, it's not only for linear regression, it's for every model. So this is a model. Sometimes this model is also known as hypothesis. Some people say it's hypothesis. So that's why we write it as H. Okay. So we learn a model. So how can we use a model? Now, if we give a new data, okay, so new input. So here we are, new size of the house, which is a new input. The model is going to give me a prediction of the price that I'm going to expect of that house. That's the estimated price. That's my prediction. Is it right, Nakina? Yeah? Clear?
Yes, sir.
Yeah, so that's the whole idea. Now the question is really very important. How do we represent this model? এই মডেলটা কিরকম হওয়া উচিত? আচ্ছা, আমার রিগ্রেশন লাইনটা কিরকম? রিগ্রেশন লাইনটা কি স্ট্রেইট লাইন না নাকি না? So if I have y, actual y and actual x, so let's say we have got some data points. So let's say these are the data points we have. And so say this is the linear regression line you found out. Okay. A regression line ta, so because we are discussing about a regression line, univariate regression line, ঠিক আছে? Okay, regression line with one variable. এটা কি একটা straight line না নাকি না? Yes? So এটা যদি straight line হয়, straight line equation কি হয়? What is the equation for the line?
So y equals to mx plus c.
Y equals to mx plus c, right? Correct. Okay. So we could say I could model the h, which is the predicted model, as equal to something like theta naught plus theta 1x. Doesn't it look like mx plus c?
Yes, sir.
Yeah. So I didn't use the word m because I'm using m to represent actually, the number of training examples. So I didn't want to confuse these two things. ঠিক আছে? So we used a fancy way of representing the model. But is it okay if I could say that the model could be represented as theta naught plus theta 1x? Is it okay? নাকি না? Yes?
Yes,
ঠিক
sir.
আছে নাকি না? Yeah, so because it's going to be it's going to be a line, and this is for univariate linear regression. It's going to be just a straight line. Okay, so this would be the equation of the straight line, right? Theta naught plus theta 1x. Is that clear নাকি না? Yes? ঠিক আছে? Okay.
Yes, sir.
So that's what is the straight line. That's the equation of this model. H theta x equals to theta naught plus theta 1x. Do not get scared because you're seeing weird parameters like theta naught and theta 1. It's the same. Y equals to c plus mx. So if you compare, theta naught is the c, m here is the theta 1. So theta 1 is the slope or the gradient of this line. Am I clear, Nakina? Yes? Yeah? So if I have y against x, real y and real x, let's say these are some of my data points we have, okay? Let's say you come up with a line like this and you say this is the straight line. Then this is my regression line. So this is h theta x, right? Okay? And this is given by the equation theta naught plus theta 1x. Now what is theta naught? What does theta naught give you? Anyone? Theta naught is same
constant
as
value
high constant value. Too simple. Class 8 mathematics.
So
Theta
it's
naught
the
is,
y
what
intercept.
is c? C gives you what? C gives you the y intercept, right? Nakina? Yeah?
Yes, sir.
Yes? That's theta naught. And what does this theta 1 give you? This theta 1 gives you the slope of this linear line. Okay? If I find the gradient, okay, so the gradient or the slope will be theta 1. Is this clear, Nakina? Are we okay? Does it make sense, Nakina?
Yes, sir.
Okay, all right. So that's basically it. So যে কোনো একটা লাইনকে আমি যদি ড্র করতে চাই, a line has two important characteristics. One is the intercept, y intercept, the other one is the slope. ঠিক আছে? And so we have both of them embedded in this model, right? But now the problem, this is very interesting. What would be the exact value of theta naught and theta 1? কারণ theta naught আর theta 1 এর ভ্যালু যদি ডিফারেন্ট হয়, লাইনটা কি ডিফারেন্ট হবে না নাকি না? Yes. Okay. So that's the thing that we need to learn. So these are the two parameters we need to learn, and we'll see how to learn them. Don't worry about that. Okay. That's so okay. So এই যে আমি একটু আগে বললাম যে we need to have different value. So we need to find out the suitable values of theta. ঠিক আছে? We need to find suitable values of theta. ঠিক আছে? For this particular training set. তাই না নাকি না? Yes? Yeah?
Yes, sir.
For the training set. Okay? Acha. Because if I don't find the suitable value of theta, I may not find a good, model. ঠিক আছে? So how do you find the suitable values of theta? This is the theta naught and theta 1. This can be found using something called a cost function. There's a concept called cost function, which I will use, and you'll see how to use them. But I will use the idea of cost function to find the suitable values of these parameters theta naught and theta 1. Is it okay, Nakina? Clear? Okay. So what is cost function and how can we use the cost function? So first of all, a cost function lets us figure out how to fit the best straight line to our data. How do you find the best straight line? ঠিক আছে? Right, Nakina? কারণ এটা খুব important. Just think about it. Okay? I want you to really, really think about this one. Okay? So let's say, okay, here's an idea. Okay, I want to keep it simple. Here's 1, here's 1. Okay, here's 2, and let's say equispaced. Here's 2, and let's say here's 3, and let's say we have over here equispaced. Here's 3. Let's say we have got 3 points, just to make it simple. Here 1 1, 2 2 তে একটা training point, 3 3 তে একটা training point. তাহলে বেস্ট ফিট লাইন কি হবে? বেস্ট ফিট লাইন কি এই তিনটা লাইনের থ্রু দিয়ে যাবে না নাকি না? Yes.
Yes.
So that would be the best fit line. Okay, তাহলে তুমি চিন্তা করে দেখো এই বেস্ট ফিট লাইন আমার মডেলের ইকুয়েশনটা কি? h theta x. H theta x means the predicted value. Predicted value can be, I can also write the predicted value as y hat. Y means actual y. Y hat is the predicted y, right? Okay, and that's equal to theta naught plus theta 1x. Okay, আচ্ছা এটা যদি straight line through the origin যায়, না তুমি চিন্তা করে দেখো আমি যদি theta naught এর ভ্যালু যদি 0 ধরি, আর লেটস আমি ধরো theta naught এর ভ্যালু যদি 0 ধরি আর theta 1 এর ভ্যালু যদি আমি ধরি 1, তাহলে আমার y hat বা h theta x কত হয়ে যাবে বলেন তো? theta naught যদি 0 হয় 0 প্লাস theta 1 যদি 1 হয় theta x হয়ে যাবে না নাকি না? Yes. Yeah, the আমার y hat predicted value would be equal to the same as x. তাহলে x যদি আমার তাহলে মডেলের মধ্যে x যদি 1 হয় তাহলে আমার h theta x কত হবে?
100.
X 1 1. That means this is my y hat. This is the predicted value. Okay, right? X যদি 2 হয় তাহলে এটা কত হবে? 2 হবে, right? আর x যদি 3 হয় তাহলে এটা কত হবে? 3 হবে. Does it go through all the points?
Yes, sir.
It goes through all the points. I could say for this particular data set, theta naught equals to 0 and theta 1 equals to 1 is the right parameter to choose. Correct, Nakina? Yes?
Yes, sir.
Okay. এখন কেউ যদি ভুল করি প্যারামিটারটা, দ্যাটস কেউ একজন আসলো, সে বললো ওকে theta naught হচ্ছে 0 আর theta 1 হচ্ছে 0.5, তাহলে কি হবে? তাহলে আমার h theta x কি হবে? h theta x would be theta naught plus theta 1x. Correct, Nakina? Yes. Theta naught is 0, fine. Theta 1 is 0.5. 0.5 is half of x. তাহলে কি হবে? তাহলে আমার x আর h theta x এর ইয়েটা কি হবে? x and h theta x. Okay. x যদি 1 বা 2 বা 3, x যদি 1 হয় তাহলে h theta x কত হবে? Half of 1, 0.5, right, Nakina? Yes. x যদি 2 হয় তাহলে আমার predicted value কত হবে বলেন? 1 হবে, half of 2. আর x যদি 3 হয় তাহলে predicted কত হবে? 1.5, right? তাহলে আমি যদি অ্যাকচুয়ালি লাইনটা ড্র করি, কেয়ারফুলি দেখেন, তাহলে আমার this is my y, this is my x. আমার অ্যাকচুয়ালি ইয়ে ছিল 1 2 3, okay, and this is 1, let's say this is 2, let's say this is 3. তা আমার অ্যাকচুয়াল পয়েন্ট ছিল 1 1 এ, 2 2 তে আর 3 3 তে, কিন্তু আমি এই মডেলটা যদি ইউজ করি x যখন 1 হচ্ছে y যখন 0.5 হচ্ছে, তার মানে this is my predicted. Actually এটা প্রেডিক্ট না করে 0.5 x1 তখন y 0.5 হাফ ওয়ে প্রেডিক্ট করছে, তাই না নাকি না? রাইট? ইয়েস.
Yes, sir.
আর x2 যখন তখন প্রেডিক্ট করছে কত? 1. আর x3 যখন তখন প্রেডিক্ট করছে কত? 1.5 somewhere here, right? So এখানে কি একটু এরর হয়ে গেল না নাকি না? So this is a linear line that you are predicting, right, Nakina? Yes. So did it predict it well or did it not predict well? What do you think? Did it predict well or did it not predict well? For example, when x is 2, it predicted a value of 1, which is here, but the actual value is 2, right, Nakina? When x is 3, it predicted 1.45, but the actual value is 3, correct, Nakina? So isn't there an error, right, in prediction?
Yes, sir.
There is an error in prediction. So what I'm just trying to say is these values of theta actually when it determines how well the model is going to make the prediction. So that's why we need to find these parameters very carefully. Is it clear, Nakina? Yes? Okay. Right, Nakina? So the heart of the problem in linear regression is to be able to find these parameters, thetas. In this case, theta naught and theta 1. Are we getting the point, Nakina? Yes?
Yes, sir.
Yes,
Yeah.
sir.
Because if you choose a different value of theta, then, okay, not a suitable value of theta, then there will be an error in prediction, okay? So how do you do that? In order to do that, in order to learn that, we use the concept called cost function. So this cost function is used to actually figure out the best fit line. So is to figure out the right value of theta that will make the prediction correctly. Is it okay, Nakina? Yes? So this cost function that we're about to discuss right now, it lets us figure out how to fit the best straight line to our data. Is it making sense or is it not making sense? Are we clear? Yes?
Yes, sir.
Yes, sir.
Okay. Let's move on a little bit. তাহলে আরেকটু clear হবে জিনিসটা, cost functionটা কি? Okay, so here we are. So far, what we have is we have a training set. So we are looking at univariate linear regression. So we have one feature and one target variable. And the hypothesis or the model that we have is given by this equation, h theta x equals to theta naught plus theta 1x. Is it okay so far? So far, so good? Yes? Yeah?
Yes, sir.
Okay, so here, theta that we have, the thetas that we have, theta naught and theta 1 in this example, are my parameters that we need to learn. If we do not learn these parameters well, okay, then we are not going to make good predictions. So, age machine learning, machine learning because we learn. So, what do we learn here? We learn these parameters, theta naught and theta 1. We learn what is the right or what is an appropriate or what is the suitable value of these parameters, theta naught and theta 1 in this example. Is it clear, Nakina? So that's what we're going to learn. So here is our question, and this is the heart of the machine learning regression problem, is how to choose the thetas, how to find the suitable value of these thetas. Okay, how do you find theta naught? What would be the appropriate value of theta naught and theta 1? Clear, Nakina? Is that okay? So I hope I already made the point with this example that why choosing an appropriate value of the thetas are important for good prediction. Is it right, Nakina? Clear? Yes?
Yes, sir.
Hello? Okay.
Yes, sir.
So we're going to learn that. We're going to see how it is. But I'm still going to give you an intuition, okay, why these suitable values of thetas are very important. Here's an example. If you change the values of thetas, your line changes. Like, for example, here's your model. H theta x is theta naught plus theta 1x. Imagine I have theta naught as 0, sorry, theta 1 as 0 and theta naught as 0.5, 1.4. So how is the line going to look like? Theta naught is 1.5, so this is going to be 1.5 plus theta 1x, theta 1 is 0, 0 times anything is 0. So for these theta naught and theta 1, my h theta x kemon hobe? Theta naught is 1.5 plus theta 1 x hobe 0, right? Nakina, clear? So it's 1.5. Yes? Correct?
Yes, sir.
তার মানে কি, whatever the value of x may be, okay, it's always going to be, the predicted value is going to be always 1.5, isn't it, Nakina? The predicted value is independent of x, okay? So using this one, you'll see that it will generate a line like this, right? 1.5. Whatever the value of x may be, doesn't matter. It's always going to be 1.5. Is it clear, Nakina? Yes? Right?
Yes, sir.
What about here? If we choose a different values of theta, like say theta naught is 0 and theta 1 is 0.5, then your h theta x would turn out to be theta naught is 0 plus theta 1 which is 0.5, which is half of x, right? So this would be half of x. Half of x means x যখন 1 তখন half of 1 is 0.5 prediction, x যখন 2 half of 2 is 1 is the prediction, x যখন 3 half of 3 is 1.5 is the prediction. So that would be my line, linear regression. ঠিক আছে? This is my regression line. Clear নাকি না? Yes? Okay? Correct?
Yes, sir.
আচ্ছা, what about for here? Theta naught যদি 1 হয় আর theta 1 যদি 0.5 হয়, তাহলে my h theta x কি হবে? Theta naught is 1 plus theta 1 হচ্ছে half times x. Okay, no problem. 1 plus half x. তার মানে x যখন 1 হবে, half of 1 কত? Half of 1? 0.5, right? 0.5 plus 1, 1.5. 1.5 means somewhere here. Okay? আচ্ছা, x যখন 2 হবে, half of 2 হচ্ছে 1, 1 plus 1 হচ্ছে 2. So x2 তে হলে এটা 2 predict হবে। আর x3 তে হলে half of 3 হচ্ছে 1.5 plus 1 is 2.5, so somewhere here. Okay, so that would be my best fit line. So you see, if I change the values of thetas, as you see over here, okay, right, my linear or my regression line changes. So this is exactly what is well, quite good now. কাছাকাছি আমি ইয়ে করলাম, ঠিক আছে? But I hope it makes sense, right, Nakina? Yes.
Yes, sir.
So the point is, a theta value randomly বসালে হবে না. We need to find out an appropriate theta value for my data set. Is that right, Nakina? Yes? Understandable, Nakina?
Yes, sir.
So what is the idea? Now the idea that we have is we want to choose theta naught and theta 1 so that h theta x is close to y for the training examples. Okay, so we need to talk about how do you find out theta naught and theta 1. I could choose any theta naught and theta 1, but I don't want to choose any theta naught and theta 1. I want to find out that pair of theta naught and theta 1 for which the predicted value and the actual value are very, very close. Yes or no? So I want to find out those values of these thetas for which the predicted value and the actual value are close. Because if the predicted and actual values are close, what does it mean? It's making a good prediction, isn't it, Nakina? Yes?
Yes, sir.
Okay, so how do we do that? For that, what we're going to use, we're going to use something called a cost function. So we are going to use the idea of cost function to evaluate how well this is actually, so we can evaluate what would be the suitable values of theta naught and theta 1. Okay, so how are we going to do that? Based on our training set, আমাদের training set যেটা আছে, we want to generate parameters. Parameters মানে কোনগুলা? The thetas, right? Theta naught and theta 1, which make the straight line. এমন thetas নেব that will make the straight line. It will always be the straight line, but chosen these parameters so that h theta x is very close to y. I want to choose those thetas in such a way that my predicted value and my actual value is very, very close for my training set. Is it clear, Nakina? Yes? ঠিক আছে?
Yes, sir.
Okay, so how we are going to do that? Okay, let's talk about that. So I can say, now this is very important that you understand that. We want to formalize this way. We want to solve this problem. Okay, we want to solve this problem as a minimization problem. So let me, I'll explain this one. What does it mean? Where we would like to minimize this thing. This is my objective function that we would like to minimize. I want to minimize h theta x minus y whole square. এটা কি clear হয় নাকি না? না clear হলে it's very fine. I will make it clear. So don't worry about that. এটা কি clear হয় that this is what we would like to achieve? না clear হলে it's okay. No worries. ঠিক আছে? Okay, I will make it clear. Absolutely clear. But this is important that you understand this one. Okay, I'll make it clear. Don't worry about that. Okay, so we're going to do things like this. আচ্ছা, আমি একটু দেখালেই ক্লিয়ার হয়ে যাবে, এটা খুব একটা ডিফিকাল্ট কিছু না। Okay. Acha. Just give me a minute. Let me put my laptop on charge and then we'll resume our discussion. Just give me a minute. Okay. Okay. Can you hear me, Nakina? Can you?
Yes, sir.
Okay.
Yes.
So let me explain you what we mean by this. Okay. What I'm trying to say is this is the cost function that we are going to make. This is a good cost function. Okay. So this equation represents the cost function. I want it a cost function Kano. Why is it a good cost function? Let me explain this one and you will understand this one. Okay. Right. Okay. So let me show you. This is very important that you understand it now. Okay. So here we are. Let's say we draw a line. This is for a univariate linear regression. Okay. All right. We plot the actual y value here and the actual value of x here. So we have a training set. Training set থেকে আমি ধরেন কিছু data points draw করলাম. Let's say this is how the data points look like. Okay, these are the different data points. Okay, ঠিক আছে? Is it clear নাকি না? Yes.
Yes,
Yes, sir.
Okay, let's say someone found out. Okay, just give me a minute. Okay, give me a minute. Okay. Okay, sorry. Can you hear?
Yes, sir.
yes,
Okay,
sir.
I'm sorry.
Yes, sir.
So, okay, there was a phone call from the NSU, so I had to pick it up. So let's say someone came up with this as a regression line. Okay, all right. So let's call it the line number L1. L1. Okay. Now let's say somebody else comes up with a different regression line. Let's say the regression line is this. Oh, sorry. Better uni. Regression line is this. And let's call this line as the line number L2. Okay. Which one is a better fit line? What do you think?
L1, sir.
L1.
L1.
মানে everybody unanimously agrees with me that this is L1 is better, right? নাকি না? Okay, আচ্ছা। So now my question is, and this is something we need to talk about mathematically. How mathematically can you say that L2 is a bad one compared to L1? L2 is a bad regressor than L1. How can you say that mathematically? মানে আমাকে তো কোনো না কোনো ভাবে কোনো কিছু একটা মেজার করে এটা ভিত্তিতে বলতে হবে যে হ্যাঁ L1 is better than L2, রাইট নাকি না? Yes, do you agree me নাকি না? Did you get my point? এটা তো তুমি চোখে দেখায় বলছো, তাই না নাকি না? Yes, but তুমি যখন কম্পিউটেশনালি করবে, you must have a way of measuring that, right নাকি না? ঠিক
Yes,
আছে?
sir.
তা মানে so ওকে, যেহেতু চোখে দেখাই বলেছেন, চোখে দেখার লজিকটাই কি ছিল? What was the logic behind that? Why L1 is better than L2?
Point close.
Okay, so the predicted value and the actual output are close, right nakina? Yes,
Yes, sir.
good. So okay, so now let's focus on that. So let's look at on this line only. Okay, so okay, let's change this to black. Okay, so I want to predict how well this line is fitting this data point. So you have said one way to see that is how well it is predicting my input data, right nakina? Yes or no? Correct?
Yes, sir.
Okay, so let me give an example here. I think this example would make sense. So here, let's choose this point. A pointer, it's just an approximate. X value is, let's say here, let's say X, I don't know, I. Okay, let's say it's the ith input, Xi. X actual value of output ekhane na, this is the actual output, Yi, correct naki na? Yes.
Yes, sir.
But what is this regression line is, what is this regression line, let's say predicting? What is the corresponding Y value is predicting for this X value? So if we extend it further, it hits the line here, right, Nakina? Yes?
Yes,
Yes?
Yes, sir.
So for this Xi, this is the corresponding Yi being predicted by the model. Am I right, Nakina? So the prediction is this one. Let's say the prediction is Y hat. Y hat is the prediction. This is the predicted output, where this is the actual output. Right, Nakina? Yes, agreed, Nakina?
Yes, sir.
Yes, sir.
So what is the error we are making here? So how much is the error? So this is a close prediction. Yes, so the error is this much, Nakina? Yes?
Yes, sir.
ঠিক আছে? So can I say that the error that we're making is equal to, okay, the error we are making is equal to Y hat I minus Yi. Yes or no?
Yes, sir.
Yes, sir.
Agreed নাকি না? Okay. Now problem হচ্ছে অনেক জায়গায় দেখা যাবে এখানে y hat I বলেছি because y hat is bigger than yi. অনেক জায়গায় হয়তো বা y hat is smaller than yi. তাই না নাকি না? Yes? Yes? So sometimes that's why we would prefer, instead of finding the error, we prefer to find square of an error. But that's not the only reason why we do so. There is another reason why we actually tend to square it. We'll see that. So let's say we square it. Square korle ki hobe? Square korle y hat boro hok or y boro hok, y boro hok doesn't matter. Square is a sum error, right? It's always going to give me a positive error, right, Nakina? Yes? Okay?
Yes, sir.
ঠিক আছে? আচ্ছা, so what would be the total error? What would be the total error? এটা তো একটা ডেটা পয়েন্টের জন্য এরর হচ্ছে। এরকম কতগুলো ডেটা পয়েন্ট আছে আমার ট্রেনিং সেটে? How many such data points do we have?
And number?
Look, we have given an interesting thing. We have said there are m data points, তাই না? প্রত্যেকটা ডেটা পয়েন্টের জন্য তো এরর হচ্ছে, তাই না নাকি না? Couple of errors হচ্ছে, right নাকি না? Yes?
Yes, sir.
So what is the error over m data points? Sum of errors, or put it like this way, sum of errors over m data points. This is the error due to only one data point, right? The ith data জন্য, right? নাকি না? Yes? Agreed? ঠিক আছে?
Yes, sir.
Okay.
Yes, sir.
What is the sum of the errors over m data points? So একটার জন্য data পয়েন্টের জন্য error যদি হয় yi hat minus yi hat minus yi ith data point whole square, right? তাহলে I'm going to sum it up for all the data points where I will start from 1 to m. Correct, Nakina?
Yes, sir.
Agreeable, Nakina? Yes?
Yes, sir.
Yes,
সবাই
sir.
আমার সাথে agree করেন? আচ্ছা। এখন, sir, think about this. What is this y hat? Y hat is denoted by h theta x, right, Nakina? Yes? Which is equal to theta naught plus theta 1x. Correct, Nakina?
Yes, sir.
আচ্ছা, so আমি এটাকে এভাবেও লিখতে পারি, this is equal to sigma I equals to 1 to m of y hat এর জায়গায় আমি লিখতে পারি, this is actually equal to h theta x. ঠিক আছে? Alright? Okay? আচ্ছা, এখানে আইটাকে আমরা উপরেও লিখতে পারি, আমরা অনেক সময় উপরেও লিখি xi ith x minus yi ith y, right? নাকি না? এভাবে দেখতে পারি না? তাহলে একই জিনিস না? Can I not write it this way?
Yes, sir.
Yes.
Yeah. So y hat is this h theta x লিখেছি, আর কিছুই লিখিনি। এটা তো sum of the error. So what's the average error? Average error কত হবে? How many data points were there?
M.
M. The average error কি 1 by m times that?
Yes,
ঠিক
sir.
আছে নাকি না? Can I say that নাকি না? Yes?
Yes, sir.
Yes, sir.
Okay. Minus yi whole square. Okay. And this is what cost function is really. So আমার অবজেক্টিভটা কি, এই এভারেজ এররটা কি, মানে এমন একটা লাইন খুঁজতে যেটা এভারেজ এরর কি, আমি কম চাই না বেশি চাই?
Com, sir.
Exactly. This is my objective. This is my objective function. We want, so this is my, okay, well, let's actually write this. Cost function is my objective function. Cost function is exactly this average error, but we are making one slight change here, which is instead of 1 by m, we write 1 by twice m. ঠিক আছে? কেন সেটাও বলছি আমি। Sigma অন্যান্য জিনিস as it is I equals to 1 to m of h theta xi minus yi whole square. Okay, is it clear? So this is really the cost function. The cost function is really the average error. Just the point is average error ke half kora hoyeche, tai na naki na? Yes, because there is a 2, that's factor 2 over there is 1 by 2 is there. Yes or no? Yeah.
Yes, sir.
So if you now see this equation that we've seen over here, this is, sorry, where it goes? This is the cost function we have, right? Nakina? And this cost function is 1 by 2m, sigma equals to 1 to m, h theta xi minus yi whole square. Is it clear, Nakina? Yes? Agreeable? ঠিক আছে নাকি ঠিক নাই?
Yes, sir.
আচ্ছা, so basically what does the cost function represent? Cost function represents the average error we are making, তাই না নাকি না? Yes? Okay, now you may wonder, you may still wonder, why did I actually put this, why did we divide by 2? তাই না নাকি না? Yes? Okay, first of all, 2 is what? Isn't it a constant নাকি না?
Yes, sir.
Yeah, so এখানে 2 লেখেন কি 3 লেখেন কি 4 লেখেন, it doesn't matter, right? নাকি না? এটা তো কোনো কিছু অসুবিধা নেই, because you're dividing by a constant number, right? আচ্ছা, 2 লেখার উদ্দেশ্যটা হচ্ছে in future you will see that এটার অনেক ক্যালকুলেশনে, ঠিক আছে, এই 2 লিখলে the calculation becomes much more simpler, equation গুলো অনেক simpler পাওয়া যায়। We'll discuss those things later, ঠিক আছে, maybe in the next class. Okay, that's the only reason, just for our convenience, we have put that 2 over there. Is it clear, Nakina? Clear now? Yes?
Yes, sir.
Yes, sir.
So আমার অবজেক্টিভ কি? আমার অবজেক্টিভ হচ্ছে কি আমি কি তাহলে j theta not theta j the cost function it's actually high cost function যদি হয় তাহলে what does it tell me? It tells me that we have what? Big average error, right নাকি না? Okay, আর j theta not theta 1 যদি কম হয় তার মানে we have small average error. তাহলে what is my objective? My objective is to have we want to find the parameters theta naught 1 theta 1 such that this one is as low as possible. তাই না নাকি না? Yes, we want to determine thetas, right, such that the cost function j theta naught theta 1 is what? Minimum or maximum? What we want?
Minimum, sir.
Minimum.
Is it clear নাকি না? এটা অবজেক্টিভটা বুঝে গেছেন তো নাকি না? বুঝেননি? Yes, so far so good. So all of a sudden suddenly হঠাৎ করে একটা equation দেখবেন, but I hope you got the basis of this equation, right নাকি না? Yes,
Yes, sir.
good. So now আমি objective function থেকে কিভাবে, how do we find out those values of thetas for which j is minimum? So for that we have a separate algorithm called the gradient descent algorithm. We'll discuss that algorithm more elaborately in the next class, but let's move on and understand মানে আমাদের ইনটুইশনটা যে কারেক্ট, যে ইকুয়েশনটা যে কারেক্টলি সবকিছু ডিটারমিন করবে, ঠিক আছে? লেটস ট্রাই টু হ্যাভ দ্যাট ইনটুইশন রাইট, ওকে? তারপর আমরা later in the next class we're going to discuss a particular algorithm that would help me to find out the parameters for which j would be minimum, ঠিক আছে? That's what we require, ঠিক আছে? Okay, all right, so now here's a intuition that we would like to discuss, ঠিক আছে? Okay, cost function intuition 1. Okay, so here's what we have so far. This is what we have learned. We have a model. It's a linear model, regression line model, with the hypothesis h theta given by theta naught plus theta 1 x. Here the parameters that we want to find out are theta naught and theta 1, but we do not want to find out any theta naught and theta 1. We want to find out that theta naught and theta 1 for which this cost function that we have, okay, is minimum, right? Our goal is to find out those values of theta naught and theta 1 for which the j, the cost function, is minimum. Am I clear or not clear? এতটুকু কি সবাই আপনারা কি আমার সাথে এগ্রি করতে পারেন নাকি না?
Yes, sir.
Yes, sir.
Agree?
Yes,
সবাই agree করতে পারেন, right নাকি না? Okay, very good. Okay, now আমি একটু আপনাকে ইনটুইশনটা, এটা যে সো ফার আমরা যেগুলো বলছি ম্যাথমেটিক্যালি এগুলো যে কারেক্ট হচ্ছে, এটা একটু মানে একটা ইনটুইশন থাকলে it helps us to মানে better rely on what we are saying, ঠিক আছে? So I'm going to give an example and I'm going to use this example to see that যতটুকু আমরা ডিসকাস করছি is right indeed. So I'm going to take a much more simplified model. I have to simplified model name, ঠিক আছে? So this is my simplified model. In this model আমি theta naught টাকে কত সেট করলাম? 0. Theta naught 0 set করা মানে হচ্ছে I'm assuming that this line that we are drawing is going to pass through the origin. Is it right নাকি না? Yes, the y-intercept is 0. So if I set that theta naught as 0, so this is out of the equation, my simplified hypothesis now becomes theta 1x. Is this clear নাকি না? Yes.
Yes, sir.
So how many parameters do we need to learn? We need to learn only one parameter, which is theta 1, correct? Because theta naught is already set as 0. Acha. Then what will be my cost function? My cost function j will no longer be a function of theta naught and theta 1. It will now only be a function of theta 1, right? Nakina. And it's given by the same equation, which is 1 by twice m sigma equals to 1 to m of h theta xi minus yi whole square. And what is my goal? My goal is to find out the theta 1 for which this j theta 1 that we have is minimum. Is it right, Nakina? Yes?
Yes, sir.
Yes.
Acha, it was actual, but I have to simplified version দিচ্ছি just to show you simplified version টা now উদ্দেশ্যটা হচ্ছে just to show you what we are saying is indeed correct. Okay, Nakina? So that you yourself are, you're happy with the idea যে যেটা নিয়ে আমরা কথা বলছি it's working ঠিক আছে so let me show you that so we are simply assuming right now for our simplified model that our theta naught is 0 so let's see আমরা simplified hypothesis টা দিয়ে খুব সুন্দর একটা visualization করতে পারি নাকি ঠিক আছে okay here's an example over here okay so I want you to see this carefully now so আমাদের for fixed theta 1 okay this is the function okay let's see here's y equals x so let's say we have got 3 points going through 1 1 2 2 and 3 3 clear nakinam yes
Yes, sir.
so this is my act well আমি theta not to 0 আমি theta 1 যদি 1 set করি তাহলে কি হবে তাহলে কি will I get a straight line like that because আমার h theta x টা কি theta 1 x না এখন simplified version
Yes, sir.
okay theta 1 যদি 1 প্লাগ করি তাহলে theta 1 যদি 1 হয় তাহলে h theta x কি হবে x হবে yes
জি স্যার
তার মানে x যদি 1 হয় h theta x হবে 1 1 1 x2 হলে h theta x2 x3 হলে h theta x3 ঠিক আছে right নাকি না yes okay so that's the best fit line that that's the you know regression line that we will find out is it right নাকি না clear
Yes, sir.
আচ্ছা তার মানে আমি যদি theta 1 1 ধরি তাহলে আমার j of theta 1 কত হবে জিরো হবে কেন জিরো হবে because predicted value and actual value is the same right নাকি না yes
জি স্যার জি স্যার
আচ্ছা এরপর বুঝতে যদি অসুবিধা হয় I can actually show that because j theta 1 was the formula is 1 by twice m yeah sigma I equals to 1 to m remember h theta xi minus yi okay sorry minus yi whole square right নাকি না okay তাহলে দেখো আমার এখানে কতগুলো ডেটা পয়েন্ট আছে বলুন তো so theta 1 ঠিক আছে তাহলে আমার j1 এর ভ্যালু কত হবে j1 1 by 2m m ডেটা পয়েন্ট হচ্ছে কয়টা ডেটা পয়েন্ট আছে এখানে তিনটা পয়েন্ট আছে so 1 by 2 times 3 right নাকি না yes okay sigma means summation প্রত্যেকটার জন্য predicted minus actual predicted কত 1 minus actual হচ্ছে 1 1 minus 1 হচ্ছে 0 0 স্কয়ার প্লাস নেক্সট predicted হচ্ছে 2 আর actual হচ্ছে 2 তাহলে 2 minus 2 হচ্ছে 0 0 স্কয়ার প্লাস নেক্সট হচ্ছে predicted হচ্ছে 3 এবং actual তো 3 so 3 minus 3 হচ্ছে 0 0 স্কয়ার রাইট নাকি না so this is 0 divided by 6 which is 0 clear নাকি না so that my j theta 1 is 0 is that okay yes
Yes, sir.
ঠিক আছে
Yes, sir.
সো সিমিলারলি আমি যদি এখন theta 1 যদি 0.5 ধরি তাহলে আমার j theta 1 কত হবে 0.58 how do I get that okay আর theta 1 যদি অন্য 0 ধরি তাহলে j theta 1 কত হবে approximately 2.3 ঠিক আছে okay so we can do all these sort of things so how do we calculate these things তো একটা জন্য তো দেখালাম বাকিগুলোর জন্য একই ক্যালকুলেশন so I can do those calculations for different theta values so we can see that we will have different values so আমি একটা দেখিয়ে দিই কোনটা আরেকটা দেখে theta 1 তো 1 ধরে দেখালাম let me show you another one let's say theta 1 0 ধরে দেখায় ঠিক আছে theta 1 যদি 0 ধরতাম কোনটা চাও 0 না 0.5 যেটা চাও আমি একটা দেখাই তাহলে ক্লিয়ার হয়ে যাবে which one do you want
0.5 sir
0.5 কারণ আমি 0 ধরছিলাম তো এখন 0.5 আচ্ছা ঠিক আছে so theta 1 যদি 0.5 হয় তাহলে what do you have a calculator in front of you guys yeah. okay remember j theta 1 এর ইকুয়েশনটা কি ছিল 1 by 2m sigma h theta xi minus yi whole square right নাকি না yeah so okay theta 1.5 is in then how many training points are there are 3 training points 1 2 and 3 so 1 by 2 times 3 got to 6 right নাকি না clear yes agreed
জি স্যার
okay summation প্রথম ডেটা পয়েন্ট x যখন 1 so বলেন h theta x হচ্ছে আমার কি বলে prediction right নাকি না predicted output is equal to theta naught plus theta 1x, theta naught to 0 ধরলাম, so এটা theta 1x, correct নাকি না? Yes?
Yes, sir.
আচ্ছা, theta 1 কত ধরছে এখানে এই ইয়াতে এক্সাম্পলে 0.5 মানে কি হাফ টাইমস x। এখন বলেন x যখন 1 তাহলে প্রেডিকশন কত? হাফ টাইমস 1 কত?
0.5.
0.5 হচ্ছে প্রেডিকশন, আর অ্যাকচুয়াল কত? x1 হলো অ্যাকচুয়াল 1, তাহলে প্রেডিকশন হচ্ছে 0.5 মাইনাস অ্যাকচুয়াল হচ্ছে 1 হোল স্কয়ার, রাইট নাকি না? সো এটা হচ্ছে x equals to 1 data point এর জন্য, রাইট? প্লাস I'm summing it up over all the data points. x যখন 2 ছিল, x যখন 2 তাহলে প্রেডিকশন কত? হাফ টাইমস 2 কত?
1.
1 প্রেডিকশন 1, বাট x2 যখন অ্যাকচুয়াল কত?
2.
2, the prediction 1 minus actual 2, that's the error whole square, right? Plus x যদি 3 ধরি, তাহলে x যদি 3 হয় তাহলে half of 3 হচ্ছে কত? 1.5, আর অ্যাকচুয়ালটা কত?
3.
3, so 1.5 minus 3 whole square, this is the summation. And if you do that, 0.5 minus 1 means half whole square কত? 1 quarter মানে হচ্ছে 0.25 plus 1 minus 2 হচ্ছে minus 1 whole square করলে plus 1 plus 1.5 minus 3 হচ্ছে 1.5, right? মানে whole square 1.5 whole square করলে কত হবে? 2.25, I guess, right? নাকি না? Divide by 6, so 2.25 plus 0.25 হচ্ছে 2.5 plus 1 হচ্ছে 3.5, so 3.5 divided by 6. If you do 3.5 divided by 6, the answer is approximately 2.3. Clear নাকি না? Is that okay?
Yes, sir.
আচ্ছা, আমি এখন ডিফারেন্ট থিটা ভ্যালু, এখানে থিটা ভ্যালু 1, থিটা ভ্যালু থিটা 1 হচ্ছে 1, থিটা 1.5, থিটা 1 0, এবং ডিফারেন্ট থিটা ভ্যালুজ এর উপর আমি ড্র করতে পারি j ভ্যালু, রাইট নাকি না? ইয়েস, সো ফর ডিফারেন্ট থিটা ভ্যালুজ আই ক্যান find out the corresponding j of that, then we can plot a graph of theta 1, different theta 1 এর জন্য corresponding cos function এর ভ্যালু কত হয়, তাই না? বের করতে পারি না নাকি না? ইয়েস,
Yes, sir.
Yes.
so we can plot a graph. So which one is the minimum j? This is the minimum j, right? Nakina, yes?
Sir.
A minimum j corresponding theta value koto? Theta 1 koto?
1.
1.
This is how we figured out that theta 1 is a good parameter to fit this model. Is it clear, Nakina? Yes?
Yes, sir.
এটা তো just calculation করে করলাম, we did some experiments, but there are algorithms that helps us to actually calculate those parameter values using the cost function. We'll discuss that in the next class, ঠিক আছে? But I hope this makes sense, নাকি না? Yes?
Yes, sir.
Yes, sir.
Yeah? Okay, ঠিক আছে। Oh, we're running out of time, so I should stop my recording right now, okay? And we want to discuss something else, okay? All right.